In this video, I'm going to be showing you how to use gamengine3d, which is another package I made. And as you can tell by the name, it's basically the same as gamengine2d, but it's the 3D version of it. So actually, before even touching the IDE, I'm just going to go through the PyPy page. So you can see the latest version is 1.8.0, and so let's get started. So I'll just explain this, and then we're going to go to the IDE. So we'll say from gamengine3d import a star, which is import everything. And then we can initialize the engine by saying the engine equals an engine instance, we're instantiating the object. And then so when you run the engine, it's going to create a new window. So here you provide the width of that window in pixels, and here you provide the height. And then background color, obviously you can say background color equals, well, you know what it means, it's the color of the screen background. And you don't, it's not like some RGB tuple or something. You can provide, actually we have a color class, so you can just say color dot light blue, or if you want to provide your own custom color, you can just say color dot RGB and then provide the RGB values, or you can get it from hex using color dot from hex or whatever you want. And then we're going to create the actual like game objects. So we're going to say the floor is a cuboid, which is a game object like type. And then the size will be a vector 3D, which is a built-in class. So it's just a three-dimensional vector where you have the x component, the y component, and the z component. So in this case, the size would be 5 units in the x direction, 0.1 units in the y direction, and 5 units in the z direction. And then you say the color of the object, which is the floor in this case, will be color dot light gray. And then the name of the object will be floor. Obviously, you have a lot more parameters, but this is just like a quick start. And then you create the player, and then that will be another cuboid. The name is player, and then the color is color dot light red. The size, so how it works is with vector 3D, if you just provide one value, then it will just set the x, y, and z components to that value. So in this case, I've provided 0.2. So it will say the x is 0.2, y is 0.2, and z is 0.2. And then we can say the position will be vector 3D 0, 1. So if you were to provide two values, the other value would be 0. So like it would be 0, 1, 0. The z component would be 0 by default. And then we're going to add those objects to the engine. So we're going to say engine.add floor and engine.add player. And then we can say player.attach. So we're going to attach a script to the player, and the script name is playercontroller.py, and we also have to pass engine.context. And I'll show you an example for that after this line. So to run the engine, we say engine.run, and then dynamic view equals true means basically we can like pan around, we can zoom in and out and stuff like that. If it was false, then it would just be locked into wherever the camera was. And then now we have an example for playercontroller.py, and we just say from gamengine3d import all, and we're going to import math also. So we're going to create a class called player controller. Now this has to be in Pascal case. So like if your file name is player controller like this, then you have to take the Pascal case version of that, and it would be like a capital P and capital C, and the rest is normal lowercase. And then in the init method, it will take the object, which is basically when you attach a script to this player, it will take the player. So this object argument or parameter is the player, and then it will also take context. Then we'll just say self.object equals object, self.context equals context, and we're also going to define self.speed equals 1. And with the context, you can see we can also have like a callback. So we'll say self.context on key held. So when we hold a key, so and the first argument is the key, so it's the up key, and then the callback will be self.move forward, which is a method we have to define. And then dt equals true means, so dt is delta time. In game engines, you usually want delta time if you want like per second, like the speed per second or something like that. And if that is true, dt will be passed to whatever callback you are setting. And then we'll create the update method, it's going to be called every frame, but we're not going to use it now, and that will take dt. And then we'll say we'll create the move forward method, and since we said dt equals true here, this will also take dt, and we'll just move forward. So we'll say the yaw equals mat.radian, so we'll convert into radians the object self.object.rotation.z. Like I said, self.object, in this case is the player, so we're actually saying player.rotation.z. So, and you can obviously manipulate it, and you have access to the entire player in this in the entire object which the script has been attached to. So rotation is actually another vector 3D. So you have x, y, and z. So in this case, yaw is the z component, and then we're gonna say forward. So we're gonna create a forward vector. It is this thing, and then we'll say self.object.position. So the position of the object plus equals the forward vector. So like which direction is forward, that's basically what that means. And we're gonna multiply that by self.speed, which we have defined here to be 1 unit. And if we just multiply it by speed, it won't be per second, it'll be per frame. So if we multiply by dt, that is delta time. So like if it's running at 60 fps, dt will be 1 over 60. That way you can have per second stuff. And then that's the readme. And then it says you can run any built-in demo with gamengine3d demo, and then the demo name, and see all available options using gamengine3d demo h. So now let's go back to the IDE, and you can first of all install gamengine3d. So pip install gamengine3d, and the latest one is 1.8.0. I already have it installed. So now so this will give you a command line interface. So let's say gamengine3d, let's say --help. This is how you would usually like explore the command line interface of any package. So you can see we can provide a demo, so that's an argument, and let's say game engine 3d demo --help or -h also. And it says here it takes a positional argument, and it's the name of the example to run, and there are the available examples are these 4: basics, messages demo, player movement, and the everything demo. So let's take a look at the basics demo. So for that we just say gamengine3d and then demo basics like this, and then it creates a 500 by 500 pixel window, and I can resize it, and I can zoom in and out with my scroll wheel on mouse, or I can use the touchpad. I can use a 2-finger gesture, and then that's how I zoom in and out. And then to pan, I can left click and hold, and I can also have to drag, and then I can pan, and I can even rotate. So that would be right click and drag. So this is how I rotate, and you can see the basics demo. Basically we just have like a plane here, not exactly a plane, it's like a floor, and then we have a light somewhere up here in the middle, and then you can see that it already has lighting enabled. And yeah, so now let's take a look at that. So we can go into the virtual environment, libraries, and then we can go to gamengine3d, which is here. And then also you can see here, after when we type the command, it says running example basics, and it also provides a path. So it says gamengine3d.examples.basics. So we're in gamengine3d examples and then basics. So if we open this, you can see that the first line is from gamengine3d. We're going to import the engine, cuboid, vector 3d, light, and color. And then first what we're going to do is say engine equals engine. The width is 500 and the height is 500. Resizable equals true. Basically this means I can resize the window. And the name is basics demo. The background color is color.light blue, and the ambient light is 0.4. And then you can see the floor. So we're going to create a floor object. That's a cuboid. The position is vector3d.0. Now you also have vector3d.up, left, right, forward, backward, and 1. So vector3d.0 basically just means the x, y, and z component is 0. And then you can say the size is vector3d 10. So in the x direction it's 10 units, y is 0.5, and z is 10 units. and then the color is color dot light gray. And then we're going to so by default it will just use the ambient light, but if we want some actual like highlights and stuff, we have to add our own light. So we'll just say engine dot add light, and we're going to create a new light object, and the position will be vector 3d, x will be 0, 4 will be and y will be 4, and then z is 0.1, and then the color is color dot white. So you also have that in the color like object or color class. And then you can say engine dot add object, we're going to add the floor, and engine dot run. So that's all that is for that demo. So we just create the engine, create the floor, add a light, add the floor, and then run the game. That's all you have to do. And then let's go on to the next demo. So we'll say game engine 3d demo, and then the next one is the, let's go with player movement. So this is actually more complicated, so I can resize this and I can use the same like zooming in and out. And basically I have a room, right? I have a room with a floor and walls and stuff, and I also have a player, which is this red cube. I can jump with the space bar, and it also has physics. As you can see, I can jump with the space bar, I can turn left, right, I can go forward, backward with ASWD. And then so I can really just do whatever I want, like I can move around all here, and it doesn't go through walls. So like you can see here, and another neat thing is it also has shadows built in. So you can see that like this part is kind of dark, that's the shadow. And I'm going to walk through the code again, but yeah, so you can see there's a shadow on the wall, and yeah, I can just move around and do whatever I want with this cube. And the shadows are still a little buggy, but now if I let's say I jump off, it's just going to keep falling forever until I close the game. And yeah, so let's go to the code. So you can see in the output, we're running the player movement example. The path is game engine 3 dot examples dot player movement. So if we go to, so this is game engine 3d examples player movement. So let's expand this to see what we're importing, and then just so that it works on every machine, yeah, on no matter what, we're going to import pathlib. You actually don't need to do this in your own, like when you're writing it by yourself, but since this package, no one can change the package unless they actually edit it. Then we're just going to have it so that it works for the all the machines or whatever. So and then we're going to say from game engine 3d, we're going to import engine, vector 3d, color, cuboid, and light. So then we're going to initialize the engine, width of 1200, height of 800, background color is light blue, ambient light is 0.3, and the name is player movement. This name would be shown in the like title of the window. And then next is a room setup. So you saw we had a room, and then the size of the room is going to be vector 3d, a 5 in the x direction, 5, y 0.5, and z is 2.5. And then we're going to calculate half the room size, which is the room size by 2. And you have multiplication, division, addition, subtraction with vector. I think you have, yeah, you have multiplication, or you have addition, subtraction with both a scalar and a vector 3d. So if you were to add a vector 3 to a vector 3d, then you would just add each component to the corresponding component in the other vector 3d. But if you add a scalar, then it would just add that same number to each of the components. And same thing for subtraction. You also have multiplication and division. So we divide the vector 3d by 2, and then we get the define a room color, just so that like it's easy to keep a variable instead of changing all of the colors if we want to change it. So we'll say color dot white, and then the light intensity is 0.3. And then we're going to position the camera by saying engine dot camera dot move to. So you have a method called move to, and then you can just pass in a vector 3d. So we have a vector 3d of the x is 0.0, y is 1.4, and z is 2.3. Then we're going to create the floor, and we're going to say floor equals a cuboid. The size is a vector 3d. So this is where you would calculate half the room size directly, instead of saying room size dot x divided by 2 or something like that every single place. you just say room size dot x. Here we're not using half of it, but we will later. Here we'll say room size dot x, and then the y will be 1, and then the z is room size dot z, and then the color will be light gray, and then the floor is, the name is floor, and then we have the position, which is vector 3d. X is 0 and y is this. That is because when you say an object is at this location, it's actually the middle of the object that goes to the location, and all the corners or whatever are drawn around the middle. So since the middle of the object is wherever we put it, so the top edge of the object will be half of the height, which is, so the height is 1, so the top edge is 0.5. And if we want the top edge to be at 0.05 units, then we have to say 0.05 minus half the height, which is 0.5. Then we'll add it, so engine.add object floor. Then we'll create the walls. It's basically the same thing, you just, yeah, so left wall is a cuboid, the position is this, size is this, color is room color, and then the name is left wall, and then we'll add the left wall. Same thing for the right wall, just these are changed. This is why we have half size, because if we were to set negative room size dot x divided by 2, and then room size dot y divided by 2, we have to add divide by 2 everywhere. And then yeah, that's, it's basically the same thing. And this is also why we defined a variable as room color. Instead of changing it here, here, and here, in case we want to change the color of the room, we could just change that one variable. And then we add that, we create a back wall, so it's cuboid with this, and then name is back, and then we add that, and now we're going to create a player. Now we'll say the player is a cuboid, the name is player obviously, and then the color is colored or light red, and then the size is a vector 3d 0.2, and then that means x, y, and z, all three components are 0.2. The position is 0, 1, 0, which means the x is 0, y is 1, and z is 0, because we only provided two values, so by default z is 0. And then now we're just going to get the example directory. This is all, you don't have to do all this. Basically it's so that it'll work on every machine since they're downloading a package. So it's just script slash player movement.py. We'll look at that after finishing this. So we'll just say player.attach the player script, which is just the path to the player script. That's all it is. And then engine.context, which is the context we have to provide. And then we'll say engine.add object player, and we'll say engine.add light. We'll create a light. So the x is 1/3 of the room width, so room size dot x, and the y is room size dot y, z is 1, and then color dot white is the color of the light, and then light intensity we defined like point something, yeah, 0.3. And then same thing here, but instead of 1/3 it's negative 1/3, and the rest is the same. And we just say engine not run dynamic view equals true. Now you don't actually have to provide dynamic view equals true, it's true by default, but that's just to show you that you can change it. Okay, so now let's go into player movement.py. So if you go into scripts, player movement.py. So how this works is, we'll say from gamengine2d we'll import or gamengine3d we'll import vector 3d, context, and cuboid, and we'll import math. Now like I said, this the class definition, or yeah, the name of the class has to be the Pascal case of whatever the file name is. So it's player movement.py, so here it has to be player movement.py with capital P and capital M. And then we'll define the init method, which is, it'll take the object, which is a cuboid. Here there's just some type hinting for better like editor like suggestions. And then the context is of type context, and then the object self.object equals object, self.context equals context. We'll define the speed, which is equal to 1 units per second, and then the rotation is 100 degrees per second, rotation speed that is. And in the gravity, we're going to define gravity. In the x direction it's 0 obviously, and in the y direction it's negative 4.8 units, and in the z direction it's 0. And then the velocity is vector 3.0. And then the movement bindings. So basically like I said in the like I showed in the readme, we have the binding. So we can say self.context on key held. So when we hold a key, when we hold the W key, the callback is self.handle controls dt equals true, which means we provide dt, and the arguments are forward. It's a list, and this is there's just one element which is a string forward. And then we do the same thing for the rest. So S becomes the argument is backwards, A means the argument is left, D means the argument is right, and for the space bar the argument is up. And we'll just say the object rotation equals vector 3d 0. And then we'll create the update method. This takes dt, it runs every frame, it's just handle gravity, and we'll pass it dt, and yeah, that's all. And then in the handle controls method, this will take in dt because here we said dt equals true, and we'll also take the direction, which is this argument. So forward equals get forward, which is over here. It just converts the yaw into a directional vector on the xz plane like this comment shows, and basically the same thing that was in the readme of the first in the PyPy page, basically the same thing, but it's a function now. So we get the forward for the object's rotation, and we say that the direction equals, if the direction equals forward, we'll set the delta position will be forward times the speed times dt, and we'll say object dot position plus equals the delta position. Now you'll see why we didn't just add all of this onto object dot position directly, and why we define delta position. That is because we're going to undo that if we are hitting any walls. So if any, basically if any of these are true, so if self.context.functions, now we're using functions dot is colliding, so this will take in two strings, so the string of the first object and the string of the second object. So here we'll provide self.object.name. So if the player, which is that's the name of the player because this script is attached to the player, if that is colliding with the left wall, the left wall has it has a name of left, so that's why we provide left here. So this will return true if they are colliding, and the same thing for the right wall and back wall. So if any of those are true, which means we're hitting one of them, we'll just undo the change. So that's why we're going to subtract delta position. And the exact same thing for if direction equals backwards, except we're going to subtract delta position at first, and then we're going to undo by adding delta position. And then if the direction is left, we'll say the z component of the rotation minus equals self dot rotate speed times dt, so it's per second. And then the same thing for right, but it's plus equals. And then if the direction equals up, we want to jump only when we are touching the floor. We don't want to be able to double jump or just keep on jumping. So for that, we're just going to say if self.context.functions is colliding. So if we are colliding with the floor, which means we are touching the floor, then we'll say the velocity.y equals 3. And so like that means we're going to go up. And then we'll say the object position plus equals 0.1. So the y position plus equals 0.1. You'll see why we have that. Here we have the handle gravity method that will take dt. So we'll say grounded equals, we're just going to check if we're grounded or not. So self.context.functions is colliding. If we're colliding with the floor, that means we're grounded. And then if we are not grounded, self.velocity will plus equals gravity times gt, because that's how you apply gravity. And then if we are grounded, so if we're on the floor, we'll get the floor using context.functions.get game object, and the name will be floor. So we're going to actually get that. And then this part over here is just calculating the top edge of the floor. So the floor's y position plus the size of the floor in the, so the height of the floor divided by 2. This calculates the top edge, and we're going to add, so like if we set the object's position to there, then the middle of the object will be at the top edge, and we don't want that. So we're going to add the object's height divided by 2, so that the bottom of the object is at the top of the floor. And then we'll say the velocity equals vector 3.0 if we are touching the floor. And then we're going to say we're going to check predicted collision next frame. Basically that means if we are colliding with the floor, or no, this is a different function. So context.functions is colliding position, and the first is the floor, so that's the give versus the game object. And now we'll provide a position, so it'll check if this position is colliding with the floor. And we're just going to say object.position plus the velocity times dt. So that's what is going to be next frame. So we're trying to predict into the future whether the object will collide with the floor. If it is, then we're going to get the floor and we're going to snap again, we're going to snap to the surface. And else if we are not going to be colliding with the floor next frame, then we're just going to apply the gravity physics and whatever. So that's how that works, and you saw the like examples of how to use context and how to use the functions and stuff like that. There's a lot more still, and so that's that. And then the last example we're going to be, or maybe not, it's a small one, so maybe we'll see the everything example after this. But the next one is gamengine3d, and we're going to view the message example. So demo messages demo. So it looks like this. I have to zoom out first. So we have two cubes, and if I press space, so it prints in the terminal here. It says message received, self dot message equals. So it's just going to print the message that it received. And let's look at that. So the it's running the messages demo, and the path is examples dot messages demo. So that is over here. Let's open this and also close these. And then we're just going to import the same things, and we're also going to import light. We're going to say the receiver script is script slash messenger dot no, the messenger script is script slash messenger dot messenger script dot py, and the receiver script is a script slash message receiver dot py. And we're just going to create the engine again with the width and height of 1200 by 800, and the name is message demo. And then the cuboid, so the first cuboid will be a cuboid. We're just going to say the name equals cuboid1, and we're going to attach the messenger script, and we're going to pass engine.context. I'm going to look at this after this file. And then we'll say cuboid2 equals cuboid, the name is cuboid2, and we'll set a position which is a small offset from wherever the first one is, and then the color is light blue. And we'll say cuboid2 dot attach the receiver script and engine.context. Then we'll add cuboid2, then we'll add a light, and then we'll add the first cuboid, which is it's called cuboid, and engine.run. Now let's take a look at the messenger script, which is in script slash messenger script.py. So this is scripts and messenger script.py. So this is all it is. From gamengine3d, import cuboid context, and then again we have to define the class messenger script. In the init method, we'll take an object which is cuboid, the context is of type context, and then we'll just assign those both here. And then now you saw we have we can call back a function, so we can call a function if a key was pressed. That was what the player movement script does. But here we can just directly check, instead of calling a function, we can just have like an if statement. So if space in self.context.key is held, so if space is being held right now, if the space bar is being held, then we'll say context.send message. So we're going to send a message to another game object. So we don't have to like have some JSON thing where we send messages through that. We can just directly send a message. We're going to send it to cuboid2. So that's the name of the game object, and the message has been the spacebar has been pressed. Obviously, it's not a string. You can just literally pass any single Python object you want. You can even pass the messenger script class itself, whatever you want to pass. You can just pass it in the message. So basically, it's saying if we press the space key, we're going to send a message to cuboid2, and it's going to say the spacebar has been pressed. So now let's take a look at message receiver, and it's the same thing in the init method, but in the update loop, which runs every frame, that'll take dt. We're going to say if we have received a message, which is if object dot received message, then we're going to print message received, which is what you saw here. And then we're going to print the last message, which is like the latest message, that by saying self.object.messages index of -1, which becomes the last message. We're going to print that, and we're just going to print like a spacer over here, so that like we can differentiate between each of the messages. And then you can see once we print the messages, it's actually a message class. So it's a class of type message, and then the message is spacebar has been pressed. Sender is cuboid1. So it will automatically log who sent it. We don't have to pass that in the messenger script. So we can just say message and it will automatically know who sent the message. So we'll get the name of the game object, and it also requires the time at which the message was sent. Now obviously you can do something with the message, and you can provide like a dictionary instead of a string as a message, but this is just so that this is how you can see the two game objects can communicate with each other without complex things or anything. You can just send messages and receive them. And then let's take a look at the next one, which is the everything demo. This is going to be a bit long, so let's run this. So when I do this, when I full screen, you can see it's just a cylinder and it's rotated a bit, it's changing colors. But if you zoom out, you can see there's a sphere and there's also a cuboid here, so I can rotate. And now watch. So if I press W, it creates another cylinder. So it's a dynamic sort of thing. It creates a cylinder there. And if I press E, the moment I press E, so it's not if I'm holding E. When I actually like push it, it generates a sphere. But it only generates it for when when I am pressing it. When it's held down or when it's released, it doesn't do anything. And when I press R, once I release it, it generates, you saw it generated a cuboid there. So that is that. And let's take a look at that. And it is the everything examples.everything demo. So that is over here. And you can see that we just have this. And then we can say context or runtime variables dot from settings. So we're going to just get all of the settings from this module path, which is gamengine3d dot examples dot scripts dot settings. I'll see that later. And then we're just getting some lights basically. So these are the positions for all the lights. You can have a lot of lights, as you can see. And then for position in each of the positions, we're going to create a light. And the lights are going the lights for now they're going to be white, but they can have whatever color you want. And then we're going to get the scripts directory. We don't need to do this again. And we're going to create a cylinder by saying just creating a cylinder, and the position is vector 3.0. The length is 2, the radius is 0.5, the color is color.light green. And then there are 64 segments in the cylinder, so obviously you can't produce it exactly like cylindrical shape, so you have to divide into segments. So there are 64 segments. The this is the this is the rotation. The rotation in the x-axis is 40 degrees, y is 60, z is 100. The name is cylinder. And then we're going to attach script slash cylinder.py to the cylinder, and we're going to add that. And then we're going to say cuboid equals a cuboid, and it's just with some random parameters just to show you that we have that the package has these like game objects. And then the sphere is the same thing, and we can actually save the scene by saying save scene.json. What that does is in the actual so I'll close this for now. It creates a new JSON file here, so it'll save the scene. You can say game objects, and it saves all of these in the JSON file. So again, you can load this again. So after you save a scene, you can load it without all of this code. So you can just throw away this code and just load it from the JSON file. But yeah, that's all. And then we're going to run it. So let's take a look at first. Let's take a look at scripts.settings. So we'll go to not here. We'll go to here. And then it's in here, and then it's examples scripts settings. So you can see in here we don't have much, right? We basically just have the cylinder colors. It's just going to cycle through all of these colors. It's a list, So you have light red, light green, light blue, light yellow, orange, and magenta. And then just the number of colors is the length of this colors list. And in the sphere position is this. Basically, we're just defining some variables here. And then here, when we say run context or runtime words dot from settings, it's going to look at whatever module path we provide, which is this. It's just going to get all of these variables and it's going to put them into, it's going to set its attributes to those. So like, I'll show you what I mean. And then yeah, that's that. And then let's go to the cylinder.py. And then this is all for cylinder.py. And you can see we're just going to import everything from gamengine3d and just the same thing here. And then we'll set the color index, so which color it is right now, that is 0. The object.color will be the cylinder colors 0. So here we're actually accessing the runtime variable. So we're saying self.context or runtime variables dot cylinder colors, and that was actually defined in settings.py. But since we said from settings, we can actually just use that over here. It automatically imports that cylinder colors. It has a list and everything. And then we'll say context dot add scheduled caller. What this does is it will like schedule a function to be called every how many ever whatever delay you give it. So if you say n times is a positive number, it'll call it that many times. If it's -1 or yeah, if it's -1, it'll just run infinitely. And then the delay is 1 second. The callback is which color. And then in the update, we'll take dt. We'll say if we press W, we will say context dot functions dot draw cylinder. The position is a vector 3D this. The length is 2, the radius is 1, and the color is colored on light green, and the number of segments are 32 segments. That's what you saw there when we pressed W, when we held W. And then if we are pressing the E, so not when we hold, if we press it, then it'll draw a sphere like this. And if we press R, it'll draw a cube like this. And then in switch color, we can just increment the self.color index, and we can say object.color equals self.context or runtime vars dot cylinder colors. Again, we have that list. And then it'll be self.color index and modulus the number of colors. So self.context or runtime vars dot num cylinder colors. So what that does is it'll just wrap around. So if we go like, since there are like I guess 6 or something. Yes, since there are 6 colors, if color index is 7, it will just wrap around because we're doing modulus. So it'll go back to 1 and it'll start at the beginning and it'll just keep going like that. And yeah, so it's just going to keep calling that, but that's what schedule caller does. It's just going to keep calling that infinitely until the game stops. And yeah, that's it for this video. And there are a lot more utilities in context, a lot more than what I'm showing here. And yeah, that's it for this video. Okay, bye.